All right. I I'm disappointed with YouTube. The app just crashed and essentially I lost what I had streamed earlier. Um, this is kind of a second attempt. We're just gonna continue where we left off. Um, just give me a minute here. I'm trying to reorient myself. This happened once before, and I'm not gonna lie, it kind of pisses me off. Um, we lost the other stream for some reason. It just froze. The app just froze, and then it crashed. And then when I got back in, it wouldn't let me continue that stream for some reason. I don't know why. Looks like the app is just buggy. So, YouTube, you need to fix your live stream feature. And that's just the way it is. I can't even end the other stream, which is unfortunate. Right, so I just literally, the only thing I can do is delete it. So, I just deleted it. Yeah, you can't even watch it or replay it, which is unfortunate, but um, I'm sorry. This last time this happened, it really bothered me and kind of ruined the mood for the rest of the stream. I'm not gonna lie, I'm a little bit bothered again because this is the second time it has happened. The app just crashes and just have to start the stream over again. But ah, God, forgive me for complaining. It's just really annoying when that happens. So, if you were watching, then you probably already learned most of the important bits. But essentially, now I have to do the intro again. We are continuing our build of the F-16, and where we left off last time was, we have the main fuselage, we have the wing, we have the wing cover, we have the tail here, the elevator, and all we're trying to do right now is work on the mechanism. And prior to this stream, on the stream that got canceled because YouTube is crap, we cut out windows, little windows for our mechanism. These are slight, very tiny openings for the pin to slide forward and backwards. So that's that. There's some manufacturing techniques here that I can quickly go over, but it won't be in detail because we lost all of that with the last stream being suspended for some reason. So essentially, you want to cut on one side, right? Just poke and then slide your knife and then kind of rotate it up so that you don't overshoot this cut. And you want to do the same thing for the other side here. And you want to cut both of these long sides first to get a good and proper cut, because if you do one side here and then poke it and cut the perpendicular edge here, then it's just harder to cut this side. So you don't want to do that. So you just cut both of these sides first and then puncture one side, right, with your knife. You use a triangular tip, and just lift that off. Once you lift it off, you can fold it over and then slice it here. So that's kind of the procedure for making these. When you mark the lines, you also want to use your finger as a guide, right? So you orient the tip of your pen or pencil to the part that you want to mark, and then you just slide your finger. And so that's a quick overview of how we got this part to look the way it did. We lost the last stream again. I am very angry, a little bit, kind of bothered by YouTube's incompetence, because literally you have thousands of engineers and you cannot solve this problem of streams being interrupted and content being lost. But anyways, both of these are done the same way, right? So on both sides, and so we're gonna leave this to the side for now. Now, going back to the actual, going forward, instead of dwelling on that, last time where we left off was, the stream that got interrupted was this bit right here. This is the path for the actuator link, right? So essentially, we have our leading edge slat here. We want to draw out a path for the mechanism linkage, right? And we essentially explain the mechanism in great depth, but we lost all of that again. I just cannot get over that. Essentially, we have a spar, a wooden spar, in the core of the wing that's going to be also acting as the static component to the bearing, the rotational hinge, right? That we want. Essentially, what we're creating is this right here. But what's holding this paperclip to the spar in the rest of the wing is tape, right? We're just gonna secure it really, really tightly with tape, and it performs really nicely as a hinge and as a moving control surface. So, with that said, we're gonna continue marking where the linkage goes out to. So, if you have any questions or comments or anything, just leave them in the chat. I'll try and respond. But again, I intend this to be kind of a live, open studio kind of a environment. So you can work on your own projects, or just watch, or just listen in. Doesn't really matter. But so yeah, this is kind of where we left off. Right, so this slat actually comes here, right, and then we overshot that by a little bit because we want to account for the fact that you have manufacturing tolerances, right? You can't bend it exactly to the shape that's the edge. You want to offset it by a certain amount because this paperclip has thickness, so you don't want to bend it right here. You want to bend it a little bit away to get that gap and proper clearance between the two parts, right? You have a moving part and you have a static part. You don't want them to interfere with each other and prevent motion from happening. So you want a little bit of a gap. That's why we offset it a little tiny bit. This, continuing on, this slat right here is going to look like this, right? And then essentially what we have here, we need like enough radius to bend this thing. So we're gonna bend approximately right here, and we want it to end, right? Because this goes for the full length. This is a full length slat, so that essentially means that your entire wingspan is the slat, right? The slat goes out here. In the M1 prototype that I showed you, there is a little bit on the tip that acts as a support for this hinge. Right, so this tiny bit here, internally, the spar continues on. And, well, I guess, so it's actually a little bit different here. This spar, as you can see, rotates, or not rotates, curves at this point right here where my fingernail is, and then it curves down, and then you can see the orange bit here. It's not transparent, right? There's a gap everywhere else but here. It's a very tiny detail, but this allows it to work. Essentially, we need to do the same thing and offset a little bit. What I initially thought when I went on this discussion here was that the steel linkage, it continued all the way out here, and then it went in and then curved. But turns out, actually, I didn't do that. So we don't have to worry about that. We do exactly what we did right here, which is, offset the thing in, because the wing literally ends here, so you don't have anything to support it outside, which is kind of obvious. That's kind of common sense, but okay, so we're gonna bend it, right, and need it to come back in at some point. So the question is just how much do we need? And last time I think I just went with approximately 1 centimeter, I want to say. Yeah, it's approximately 1 centimeter of reinforcement for the hinge. So essentially what we're trying to do is have enough area or have enough length for the mechanism to be supported without having it, just flop around and become disconnected from everything. So with that in mind, we can mark out. So this is going to be useful, right? We need to align this edge with where the mechanism starts. And then this is kind of where the wingtip ends, right? This is where the wing ends. So we need a 1 centimeter offset of length, right? This little bit of length here before we can start doing our other stuff. That's very specific here, but I'm just gonna zoom in a little closer so you guys can see. We line the outboard tip here with that edge, right? We mark 1 centimeter in, and then we want to go up, right? Leave enough radius here, right? And then just kind of connect those two lines. This is kind of the edge that we want. And, I did it with the edge of the paper, so it's a little easier to handle. But also this edge is perfectly straight, so we can bend our part to match exactly that. One thing to note about this mechanism is that this linkage is, it has to be, spaced apart slightly. So this is 0.8, this is whatever it is. But essentially what I mean is this has to be vertical, and then this has to be flat. So the bends are not in the same plane, if that makes any sense. I mean, they're in this aircraft, they're in this plane, but you have, like, if you look at it in 3D, essentially we have, our plane like this, right, and our wing like this, and we're making the mechanism. The mechanism itself, right, if this were the wing, and you have your tail here, and your whatever, the mechanism at its root is vertical, and then it comes out, right, and then you have your leading edge slat, which is going to be flat, right? So this is kind of hard to wrap your mind around if you're not in, geometrically inclined. But this is out of plane. This is in a perpendicular vertical plane compared to this this rest of this mechanism, right? So there's two different bends. They're not in the same plane, so you gotta be aware of that. So now that we have the path marked out, we can actually start bending the actual piece here. So again, sorry for the beginning of the stream. I apologize. I kind of got angry a little bit and lashed out, but technical issues, they happen, right? Just gotta continue on and keep on trucking. So we can actually start bending this now, and to do that, you're gonna need a little bit of help. So before I used this. This is like a pair of pliers. These are not that great, right? They don't have any teeth, and they're not great for twisting or anything. So I'm not gonna be using this. I actually bought a new set of pliers here. So this is slightly different. This is a little bit more hefty. It's a little bit more heavy duty. But it is what it is, right? This has, you know, grooved teeth, so that'll be useful for twisting things. It's just a little bit more beefy, which is good. But we're not gonna use this immediately. We're gonna use our hands first. What we need to do is make this into a straight piece of wire, right? And that's, you know, we need this starting material. So if you have like stock, very thin metal wire wrapped in a large, you know, tube or whatever, you can use that too. You don't have to use a paperclip. This is actually, you know, harder to deal with, but it's widely available. That's why I'm using it. So we want to use a straight edge here. Hold one end tight against the straight edge. Right. Apply force downwards and towards the ruler. And just kind of bend this bit out. Right. It's going to have a little bit of curve. That's why you bring it over here and bend it carefully to fix the to make it straight, essentially. And this is an art in and of itself. So if you can buy straight wire, please by all means do. It makes this step a lot easier. But we're just prepping the wire, prepping the paperclip for further steps. And the straighter you can get it, the better, right? Because this part is going to be rotating and moving, so you don't want any, you know, curves and offsets and whatnot. So you want to shift your ruler back and forth to make sure you get an even bend. You don't want to bend it in one place because it's a curve, it's an arc, it's not an angle, right? So you have bends in multiple places. So this is pretty straight. This is good enough. Sorry about that. Let me just move this a little bit more to the area where I'm working with. And then, you know, just do the same thing, right? Pinch this really hard against the ruler, down and towards the ruler. And then just kind of bend this into shape. And this is kind of, yeah, this is finicky, but what are you gonna do when you only have paper clips? So just kind of do that, and you know, you just do the same thing again, and just kind of bend it so that this last bit is going to be a little tricky because there's not enough in-plane reinforcement support to prevent it from rotating. So it's when you try and fix it, it's going to want to rotate, which is unfortunate, but it's a part of the deal. So we have a straight wire now. You know, we need to do the same thing for the other side. So when I work on these mechanisms, I usually like to do both sides at the same time. When not like at the same time, but like simultaneously. That's to prevent me from forgetting like a step along the way. So we're gonna do this again because we're in that mindset. This is like, oh God, this is like in grade school when you practice your cursive or letters, you know. I guess it's not really applicable to English schools, but when you're writing, for example, Chinese characters in practice, you know, as a kid, I didn't realize this was not the right way, but to be efficient, I do all the strokes in all the little tiny boxes where you write the characters in. I do all of those strokes identically, and then, you know, the next stroke, and then, you know. So this is like kind of mass manufacturing, essentially. We're doing the same thing here, except for parts. And this just makes the parts better because you're in that mindset of doing this step, right? So you already practice on this one, so you're just essentially replicating what you did, instead of, you know, making this part to completion and then starting again. That's like, you're gonna be a little off in your manufacturing process. So unless you have like a CNC metal wire bending machine, which I don't have, so I'm not going to use that, obviously, because I don't have a machine like that. But you get the gist, right? You want to do both at the same time, or not at the same time, but like simultaneously, like one after the other, consecutively, right? That's the word. And then that'll help you create consistent parts. And that's just human nature. So this is relatively straight, except the end bit here. And it doesn't have to be perfect. It just has to be to the best of your ability. That's that's, you know, my motto, I guess, in general for life. It doesn't have to be perfect, just to the best of your ability. So I'm just gonna fix this manually. This is the end bit here is the hardest bit to make straight. But if you have stock wire, please use that. Don't spend time straightening paper clips. That's a waste of time. All right, so we have our plan form here, and we're ready to do some of the bending here. This is a new tool to me, so I don't know how to use this, but we're gonna go ahead and try anyway. This length matters, but where or how it's oriented does not matter yet. On the other side, this is gonna be inverted, so you want to make sure that you understand that. And let's see here. This is essentially the height. And you want this to be a 90-degree bend. So once you grip it in place, make sure it's 90 degrees, right? And then just bend it. This is like a very... Right, so essentially we're bending this rod to be like this. So there's a little bit of give, or rather tolerance issues, but I doubt it'll make a difference. So if we just test dry fit this neutral point and then this mechanism, so it's approximately the height of what we have. It's a little higher, which is okay because that's perfectly fine. Shit, I forgot. All right, so we actually need. All right, I'm gonna fix this. All right, so I didn't plan this properly. Another thing that you have to do to make this mechanism that I neglected is you need to make a tiny little loop on the end. So this is, you know, this goes back to the M1 prototype, right? This is how I did it in the past. Is you see this little loop here? Right, yeah, don't bend the wire yet. You need this little loop, and you need it to secure an elastic band. This elastic band is important. It's not trivial. It's you need it to maintain a certain tension on the part. The reason I say this is you have one pin that's sliding this mechanism, right? You have a pin like this, and then you have a 90-degree thing, and you're turning it like this, which is turning the slats, right? Moving it back and forth. But how are you going to get it back, right? So if you don't have two pins, you can't really do that, right? And the reason why we don't have two pins is it's rotating along this axis. It's not, with this axis. So this is really a strange mechanism where it interacts with the core here. It's you'll have to just trust me on this, but you need an elastic band to maintain a certain level of pretension, to make sure it doesn't shift around. So I bent this piece back into straight form, which is okay. It's not too damaged, but we need to make that little loop and secure an elastic band. I'm trying to find an elastic band right now, so just give me a minute here. It's very finicky part. I'm trying to find where I left it. I had like a packet of these, but I cleaned off my desk. Now it's just kind of lying somewhere. Crap. This is not good. On a live stream too. Damn it. Just trying to find it real quick. Okay, so they're not like this. They're not rubber bands like this. Just saying, FYI. These are a lot smaller than that. Although you could use it. It's just you have to maintain enough tension, which I don't know if because the size of that rubber band is just going to require too much movement. Yeah, I don't know where the packet went. That's all right. Well, let's see. It's here. Shit. Literally, when I need it, it just disappears. I'm a pretty organized person too. All right, well, I can't find it. I'm gonna have to improvise. No, that's not gonna work. All right. This is a critical part that I just don't understand how it could just disappear like that. now my drawers are stuck. So just hold on tight there. Just work on your own thing. Oh my god. Nothing is working for me today. Damn it. It's not an open back drawer either, so it's not easy to fix. Damn it. Jesus Christ. Alright, I fixed the drawer, but still don't have the elastic bands. God, this pisses me off. Like, nothing is going according to plan today. Jeez. Like, oh my god, like, how? It's literally always there, the packet. But apparently not. I don't know. I literally cannot proceed with this mechanism without those elastic bands, because that is a critical part. It's a very important part. All right, I think I found it. It's tucked away deep inside the drawer. So, take that as you will. Sometimes staying neat is not working to your advantage. I tried to stay neat, and essentially lost approximately 10 minutes of the stream searching for rubber bands. God damn. Anyway, just putting this back where it belongs. I might need to get more of these soon, but my usage for them is actually not that much, so I don't know if I'll buy more. But these are probably really cheap. They're like dental orthodontics, 4mm, apparently in this case 3/16 of an inch elastic bands. So as a kid, I had braces. We got a bunch of these to help correct our overbite, but we had leftovers. So essentially what we're doing is we need 2 of these. I think I only used 2. This is like a very niche, very specific part. You could get away with using a rubber band, but it's just a lot more difficult because it's huge. You need to figure out how to make it work, which I don't quite honestly want to do. So sorry about that. That took a while, but we're gonna try and make it to 2 hours and 9 minutes, and that's like approximately 130-ish minutes. Right, it's like 120 plus 9, which is 129. So usually that's the length that I go to for these streams. So since we missed the entire beginning half of this is kind of, we're gonna compensate by by going to that length, and well, we already got to this, you know, whatever. I'm just thinking to myself at this point. Doesn't really make sense, but all right. Yeah, I just need I'm just not in a right state of mind right now to stream. Just nothing going according to plan, and you know, with the technical glitches, but Jesus, just makes my day. All right, zoom out a little bit. I need some room for this. You want to create a tiny loop, just enough to wrap around an elastic band and hold it in place. This is going to require some precision, so bear with me here. Yeah, you really have to do this really carefully. It's going to be kind of hard because you want to bend a really tight loop. This is tough. This is not easy. I think I broke a plier last time doing this. It's not friendly if you don't have the right tools. You definitely cannot do this with your hand, with your bare hand. So you want to kind of just arc this, right? Bend it a little bit more. Pinch this down, and it's a very, very precise bit here of precision engineering. I want to loop that in, make sure it's stuck there, and then kind of just use the pliers, and it's not really focusing right now, but you want the lip of the plier just to barely touch that, and just kind of pinch and then close it in on itself. That's kind of how I did this bit right here. Right. So this is kind of tight. Make sure it's secure. And then we want to bend it back, kind of straighten it out, make it symmetric. This is actually a lot easier with this new plier that I got. This is a Craftsman. Highly recommend. Get it off of Amazon for like 17, 20 bucks. But it's like a tool that stays in your arsenal for a long time. So you might as well get a good tool. So this is kind of what we have right now. It's a symmetric, kind of like a question mark, right? A little bit. And then we're gonna essentially continue building our mechanism based off this template here. I'm gonna label this template, so that we don't lose it. This is the slat linkage. Template. Cool. We won't throw this away because I labeled it. Hopefully. Future me, please just don't be angry if I'm stupid right now. I'm not in the right state of mind, but right. So yeah, quick sip real quick. All right, so we have this. We need to, so this loop with the elastic band here is gonna be at the top, right? So we're gonna put the loop above the end point here, and then actually we could do this. Use a Sharpie and then mark out kind of where we want to bend, right? So I'm going to mark inside the bend, not outside, but inside the bend. Essentially, we want to hold with our pliers and see this little bit of black, right, being marked down here. This is, if you see this black, that means you have enough radius to curve this part. So we're gonna try and recreate the same thing for the other side, right? Because wings, you know, there's two of them, and you gotta maintain symmetry. So we've got our tiny elastic band here. It's not an O-ring, it's a 4mm elastic band. Again, you can probably get it for really cheap online on eBay or something. But I got these when I was a kid and had my teeth done for orthodontics. So just making use of leftovers. So right now, just bending this really tightly against itself. This has to be a really tight loop to save space, really. You could make it larger, but it's just not as efficient of a design. Right, and then just gotta, this is the tough bit here. Just bend this out a little bit. But gosh, alright, God, you gotta be careful when you do this. You don't want to hurt yourself. Alright, you really should be wearing safety glasses when you work with metal bits, because it's it can really damage your eyes and things like that. So, alright, so before we do that, I'm just gonna move that real quick. Sorry if I'm not capturing this on camera really well. This is a very finicky part to make. Alright, if you have a plier with you know, these teeth, you can actually grab it, I just discovered, and twist, and it'll bend it into shape relatively easily without having to apply any normal force. Just apply it like a frictional force here. And we're just gonna close this off. This is very finicky. I'm just gonna move my camera up a little bit so we have enough room. This is gonna fold down, pinch in, right? And we're gonna have to straighten this out. Alright, so it's like a little question mark that holds the elastic in place. Right, so this is a pretty good job. So this part is gonna get mangled. It's like very tightly wound, but you're gonna need it to be really done well. So don't be afraid to mangle this part up. This is just the plastic bit, plastic layer on the paperclip coming off, and you can kind of see the steel underneath. So that's no big deal. It's just a little surface wear. Okay, so we have both of these done, and we just need to continue with using the template. So we already marked out the bend point here. And basically just want to, okay, so let me just think about this for a second. If we have the slat like this and pulling back, we probably want it to be pulling back like this. Okay, so what I'm thinking about right now is you want the slat to retract to its normal position, so you want the elastic band to pull back, and you don't want it to potentially leave this tiny loop. So when you pull back, the linkage has to be oriented like this, right? Because that way it won't attempt to slide out this little opening right here. So you want it to be oriented like this, pulling back, and 90 degrees like this, going out. So actually this mark, so we want it to bend like this out at us. So actually transfer this mark to the other side of this. Okay, and this is the side that we want. And then we're gonna grab this, oriented at 9 degrees. Not bad. It's a little tall looking. Maybe we should include the loop length. But essentially what this is going to do is it's going to rotate like this when we deploy our slats. Push this forward. I guess it's not too bad, but let's actually look at this a little bit more closely. Well, maybe we should make the endpoint here the center of this loop instead of the bottom of this loop. Center or top. If we make it the top, I'm afraid the mechanism is going to encounter some bondage, or not bondage, that sounds weird. Like it's gonna like stick essentially. So let me just bend this back to its original shape. Again, you don't want to do this too much. You can do it once or twice, but you don't really want to bend a piece of wire too much because it's gonna cause it to fatigue, and then it's gonna break. So you don't want that. Shoot, let's see. Let's move it in a little bit because that seemed a little high earlier. Let me just mark it out with a Sharpie marker. So if we do it right here, that's actually a considerable amount. And then we want to bend it out from here. So that's good. Just lightly cap that for a second. right, this is a good bend. It doesn't quite look like 90 degrees. All right, it's a little bit off. But let's fix that. Really easy. Just hold on to it and bend it a little bit more. All right, that's a good bend. That's really precise, actually. Wow. Yeah, you definitely don't want to break this rubber band, but it's relatively resilient. This is designed to last inside your mouth. Like, this is supposed to have elasticity inside your mouth, so it's really tough in that sense. It's designed for harsh environments. So this is actually perfect. It retains its elasticity really well. So I want to get these orthodontal kind of small diameter rubber bands, elastic bands. They're really useful. Okay, so we have this bend, and just need to. So this is already offset. So we already designed that properly. Let me just do the same thing real quick to the other side before we lose track. So on the other side, it's gonna bend the other way, essentially. This is it's kind of tricky. So with this side, we aligned the center. Right? Yeah, we aligned the center of the loop. So we do the same thing here. Align the center of the loop. Have a mark right there. And we're going to bend it outwards, which we marked on the right side for that. Alright, pinch down at 90 degrees. It's a little bit over. Maybe bend it back a little bit. Let's see if it matches. It's a little bit higher than I wanted. I'm gonna fix this. I'm gonna bend it back. Shift this up a little bit. This is finicky. It's not very straightforward. Stop rotating, damn it. Alright, there we go. Is this a match? That's closer. Yeah, that is much better. Alright. That is really nice. Just need to bend this 90 degrees, right? good. Okay. And then, so it's essentially like this. And then we want the bend here, this plane right here. So mark out where make this bend. To have enough radius, I think we're gonna mark it on the inside here. At that location, but on the inside. Just making sure it's aligned perpendicularly. Okay. This is a little tricky. I'm just gonna fix this, reset that. I have another one here, another set of pliers. This might help. This is 90 degrees. Let's see if this works. Yeah. This pen needs to be really, really tight. So to do that, I'm just gonna do it by hand. You don't always have to use a tool. Tools are meant to help you, not prevent you from doing something. So this bend matches that. Bend it a little bit more. Yeah, so this is what I mean by out of plane, right? This bend right here is not in the same plane as this bend. This is perpendicular to the body, right? It's directly into the body right here, like this, perpendicular to this plane. But this bend right here, that's right in the plane. So just seeing if this works. Again, this is, you need dry fit everything. This is the right slat, so we're all set here. But I guess we could look at this and see if it works. Neutral is right here, right? Our slat is right about there. Draw a straight line, right? This is good. Right, and then this is gonna bend over here and then do its own thing. But for the most part, this looks great. Maybe a little bit more. to really match that shape. Again, we don't want it to be too close, because that would cause it to bind and whatnot. So, right, you need to leave this little edge here. This is a small detail, but this curve has to be able to bend over this piece right here. That's why we have this gap. We don't want it to be too close. We need it to have enough room to bend. Even this might be a little close, actually. Let me just lift it up and test it out for myself. Oh, this is fine. This is fine. Yeah. But that gap, you need that gap. You can't just do it like tight against it. So it's just how it is. All right. Before we move on, let's do the same for the other side. This is why this takes a long time. It's kind of annoying. But it's necessary. That's for that slat. This is for this slat. So symmetric, right? So we want it to bend at the same location. We can actually just match it up. Mark out this location here. So I'm imagining this rolled down flat is gonna be a little ahead of where it is, right? That's just a tip there, and then I'm gonna try and bend this into the right shape. Again, first one's hard, making sure it works, but the second one you can just copy, try and match what you did for the first one. This might be a little off. Nope, looks good. This one's gonna be a little tough to. Again, we don't have to use tools. Just try and shape it with our hands too. Alright, so this looks like it's. If we iron out this curve, it will be approximately the same length. So this is gonna be interesting. Alright, so this looks like a slightly better match. I'm just gonna try and bend this again a little bit. There we go. That's looking a little better. Yeah, that's much better. All right, then try and bend this. Try and match that side, yep. Looks pretty straight to me. Just need to get the right angle now. Just a little bit more. Yep, it's an angle match. Maybe a little wide. Just a tiny bit more. Yep, looks good to me. So this will just be this side right here. I just need to straighten out some of these defects. There we go. Looks okay. Doesn't look too bad. Just gonna make sure. Alright, so angle needs a little bit more. Yeah. Alright, that's good. Alright. And then we need to bend it again. And this time it's slightly different. This one's on this side. This is the one on this side. Yeah. All right. So we bent it these 2 times, and then now we just need to bend it again on this side. So if we test this out on a slat, this part is going to fit right about inside here. And then it's going to curve back out. So we're going to need this to come back a little bit. Give it enough room to bend. Right. This part is going to be a little tricky. It's a very tight bend again, like this one, but this one, you know, you have a smaller area here to work with. But I guess, you know, it's the same on both sides, but you want to be careful here. Alright, so this is does that make sense? This is what we have. Now we just need to bend it more. sure it's, sorry about that. Make sure it's perpendicular to this plane. God, this is so painstaking. Just making sure it's good here. It's a very sharp bend, which is not great to make. It's not very easy to make. That's kind of what it looks like right now. Just gotta straighten this a little bit. This is not an easy thing to do. Again, you can do it rapidly, do a bad job at it, but it's not what we're about here. So we're gonna take our time here. On the outside, it creates a tighter bend. To make this a little bit easier on myself, I'm going to draw the outline of this slat. To visualize where it is. That looks good to me. This is where we want the next bend to be. So we'll just briefly mark that out. But we have another part identical to this that we need to make. We can trim the excess, so no worries there. Just need to replicate what we did here on the other side. Mark out this side. Match this up. This is very, very frustrating. A lot of headache making this thing. Okay. part is really hard. Sorry, I'm just really focusing in on this. Not an easy thing to do. Just looking at this right now. Checking for symmetry. Looks like it needs a little bit more. Looks good. Looks good. We just need to straighten out that little bend there. This little bend is the last step for this really tight bend right here. Just need to increase this bend again back to its proper position. Check for symmetry. This might be a little too much, actually. Yeah, it's a little too much. Just the outboard. Check for symmetry. It's relatively symmetric. This part is just bent a little bit. Okay, that looks all set. Just try and match it up with this. This isn't gonna match perfectly because it's on the other side, but it should be pretty close to the actual thing. If you hold this up, matches pretty closely. Might be a slight deviation, but we can live with that. It's not going to be perfect because this is handmade, it's not machine made. If I were a better craftsman, this wouldn't be a problem. You see this little offset here? But we got it to be pretty close, so that's good enough for me. It's gonna serve the same function. It's gonna be fine because it's well, this one is the right, this one is the left. The left one just has slightly larger bend radii. But they're both clear of the inboard static portion of the wing, so we should be all set there, right? So it's gonna look like this on this side. This is the left side. This is the right side. It's going to turn down like that to deploy, right? This radius is just a little big, but we can deal with that. It's gonna be wrapped inside this slat anyway, so we can deal with that. Now we just want to do the last bend out here. These two bends are going to be easier because these are obtuse angles. If you notice this angle right here, right, this angle, and then this angle right here. So this and this are both obtuse angles. So that's a lot easier to bend. We could have done that here with two obtuse angles, but that wouldn't have matched this shape all that well. We want to match this shape because we want to give this corner of the slat a little bit more rigidity, right? We don't want it to be kind of empty space and with no reinforcement. So the way we did it, I think we should be okay here. This is more painstaking, but it matches the shape more closely. Closer, I guess, is the proper term, but now we just need to make this outer bend right here. So we're at 91 minutes, so we've got approximately 30 minutes left. Let's see how far we can get. Once this is done, the actual integration also takes a hell of a long time to get it precise, right? It's a lot of finger gymnastics, if you will. Just taping, applying the bearings, and just making sure everything's secure. So, this is all right. This is not bad. We made some good progress. Hopefully, this stream doesn't quit on me. Fingers crossed. Take another sip. Okay, this should be quick. Okay, we marked out the location. Just need to pinch this and then bend it inwards. Actually, let's use this one. This one is okay. This is maybe a little too much. We can easily bend that back out. Let's see if it works here. Yeah, it's a pretty good bend. Yeah, it's a little bit outward, but that should be okay, as long as we match it on the other side. fold in, fold the outer side. Okay, good to know. This is obviously too much. Bend it back. Okay. This looks decent. Okay. Just gonna make sure rotationally they're not out of plane. This is slightly out. Okay, let's see. This is good. And then another bend here. This looks decent. Okay. And we just need to do the last bend. Jeez, that's really tough. Okay, we need to bend this back out. You notice I'm holding the part that's already bent. We don't want to hold the outside and then bend the inside because that would change the bend on the inside. If that makes any sense. Okay. Maybe a little too much. There we go. Okay. This looks to be pretty decent. Maybe a little too thick though. We need an actual part to test this out. If we fold this slat around, will we have enough clearance? This gap is a little big, so we need to fix this one. Is this better? This looks a lot better. Just a couple of millimeters difference. Yeah, that's a lot better. This might be a better fit. Just gonna pinch this in a little bit. Sharper bend. Very finicky. Very, very, very finicky. Okay. And the last bit here is to just mark where to cut off. We're not gonna do the cutting now in case we need to make some changes, but we do need to try and replicate this on the other side. About right there. Maybe too much. Much closer. There we go. Did that do the job? It looks okay. Does it fit okay? We need the left slat. This is the left side. Fold this over. We have there's a tiny gap. Let's see, what about the other side? This one is the right slat. Fold it in half. It just barely covers it. So this one is a good fit, but the other one, the left slat over here, on the other hand, is not precise fit quite yet. Looks like we need to end this outer bend a little bit earlier. Pretty good. If we match this up, looks a little better. A very slight change. This is the left side. This is the left slat because we labeled it earlier. Now if we do a fit, that is much better. Wow, okay. That's good. That's good. All right, so we're almost there. I just need to mark out that last part where to make the cut. Right about there. Shape is still a little bit off, but I think it should be okay for the most part. We can make it conform. Right, this isn't symmetric, is it? I guess it's symmetric. It's just a little bit off. It's not too big of a problem. We will be able to solve this problem. For the most part, this is symmetric. Sorry about that. I wasn't looking at the screen, too focused. Pretty good. Not too bad. It's not going to be precise, exact, but for each side by itself, it'll definitely do what the mechanism was intended to do, which is to move the slats. It's great. The nice part about the bottom side is you don't need the little brass fasteners. You don't need these little guys to create the bearing, as opposed to the other one. Because when the bearing is spar itself, then you just need tape. Right, so this literally is going to be taped to this rod really tightly, and then it's going to be okay. It's going to be all good. And this side is going to be right here. Pretty close. All right. This should be good. This should be good. Just need to integrate it with the spar and slat surface, which we might have to do next time. We're at 109. Usually I go to 120, 130. So we have like 20 minutes left. But yeah, this is good. This is good progress. We just need to cut these off, which I think we're just about ready to do. Yeah, it looks good. It looks good. This is kind of what I'm seeing right now. Sorry about that. I wasn't in focus or didn't adjust the camera, but this is kind of what we have right now. Let's move this closer, get a better view. This is the mechanism, right? This is the actuator arm, the link, and it goes out until here. We're going to be cutting that off. This outer portion we're going to be cutting off. But essentially this flat bit and all of this down here is going to be taped really securely to this. And then the slat surface is going to be wrapped around this structure. It's going to be taped. So that is a very tight integration, which I don't know if I can complete today. That's going to take more than 20 minutes. But yeah, that's kind of the gist of what we're trying to do. So we're going to tape this to this, tape that to that, and then assemble this onto this and this. So the whole slat assembly will be one part. It'll be essentially the slat and the spar, and that's pretty much it. With this, rotating bit here, right? These two parts are rotating. This holds, this middle part here holds the slat in place. Right? So you can imagine this wrapping around this part here. And then the trailing edges are gonna have to be taped, right? And then this part gets taped to this really securely, probably double or triple layered of tape. Just binding this to this, and then same thing on this side. We're gonna tape this entire length to this as close as we can, right? So this isn't a perfect popsicle stick. I mean, it's a good popsicle stick, but it's just, like, we're not gonna match exactly at the center, right? We're gonna have to mount the popsicle sticks at a certain location. We're gonna have to trim off the excess here. It looks like it's a little long. But if we're gonna start trimming, then we might as well sand this down to match, right? To make it align with the center line. And then so yeah, so cut this, cut that, make sure this is aligned with this edge right here, right? Align all properly. And then probably assemble this to this first, right? The surface, the actual surface to the, no, we can't do that. You have to attach the, oh God, because this has been a while since I've made this. You have to attach the actuation link, the orange wire, to the, shoot, what happened here? Yeah, orange wire to the spar, here and here. Tape it really tightly, and then you gotta finesse, right? And then it's this onto this, but this is already bonded to this, so you're not gonna have a lot of space to work with. So you gotta be careful there, and just try your best to do that. But we're not gonna do that today. I don't think I can finish it in time. We literally have like 6, no, not 6, 10 or so minutes left. But I don't know. It's a good thing to do for next time. In the time that we have left today, we can start aligning and trying to like match the just tailor the wooden spars, paper, not paper, the popsicle sticks to the actual wing, and then we can start going from there. I think for this plane, I might actually do dual popsicle sticks for the wings, just to make it a little bit more rigid. And also, you know, it's, God, some of these popsicle sticks are really curved, so we can't really use them. I'm trying to find one that isn't curved right now. I'm trying to find one. Yeah, essentially we're gonna, this one isn't perfect either, but we'll have to make do. This is gonna be right up against that. And then we're gonna create another one, a secondary one, that is gonna complete it, making a triangle here. That's gonna make it really rigid, but it's also gonna help support, give it a little bit more thickness back here. You don't want it to have like 0 thickness here for such a wide chord. This is a pretty big chord. It's like a delta wing. It's like a triangular wing here. So we want to reinforce it in the back too. And since we're cutting it, we can cut this to match this as well. But yeah, we just need to tailor the spars. So that's the first thing to do next time is tailor the spars. Right, cut it to spec. Right, cut it here, and then we tape the orange to the spar, and then we tape the gray to the orange, the spar or the slat to the surface itself to the orange bit, and then we assemble the rear spar. And then we put the friction lock, the core actuation mechanism in place, right, with the pin. Okay, so I lied earlier. I mentioned we didn't need a brass fastener, but it seems like we still do. Oh, moved it a little bit. Just gotta fix that to align it. We still need one to hold this in place. You know, these 2 elastic bands, they need an anchor point. You can't just like, you know, have it tied to the main straw, because that's going to cause some compression and it's going to mess with the center actuation mechanism. So you need an anchor point, right? This anchor point is, well, it's not going to affect the back part, I think. You could, no, it's not going to stretch that far anyway, so. Yeah, I'll probably do like a spar right here, and then use a fastener. Either somewhere in the middle or behind. I don't think this is gonna stretch all the way back, to be honest. It's not that stretchy. Alright, let me just move that a little bit. Move this closer to where it's going to be, to have a better idea. is probably gonna get shaved off right here. This, so that it fits flush with this. It's gonna make a really solid structure. This, and then we have this. This is kind of like me just thinking out loud here. Right, we're just gonna attach this in the middle here, at the midpoint between this spar and then the end of that spar. Just make it clean. That'll look okay. Right, so you want it to be like that, so you don't cut the elastic, right, when you stretch it over this thing. And then it should have enough pre-tension, but we need the pin in place too. So this is where mechanism design gets really tough, is everything has to fit together all at once, and there's really no way around it. You just kind of have to work one by one through all the things. So right now, priority is tailor the spars. Once you tailor the spars, you attach the metal rod. Once you attach the metal rod, you attach the paper surface to the metal rod. So you have an assembly. You have two of these assemblies, right? And essentially you need to put it so that they're aligned, right? And then you tailor the rear spar here. It's going to be flush against this, and then you have your center mechanism. So I think the center mechanism is gonna take a little bit, because we need to get the rear elevator done first. Because once that assembly is done, right, you're gonna have like a pin here with the arm linkage with the kind of wound structure that's gonna grab the two control surfaces. You need to make that first, make that done, and then attach the anchor points later. The reason for that is once you have that assembly done, you can put it into neutral, and then whatever is here, you can, poke a rod through and have that pin there ready to go. Because otherwise, if you do this pin first, then this neutral point, you have to assemble it later. So I feel like it would be easier to do this one first and then this, if that makes any sense. That's kind of just me thinking out loud, just trying to make some progress here in how we're going to proceed. But for the most part, I feel like this is pretty good. It looks good so far. Again, I've tested this mechanism on the M1 Astra prototype, so it's proven. It's just I need to do it again. And this time around, it's not a single mechanism anymore. It's connected to a secondary elevator mechanism right here in the back. And that's gonna cause some headache, to be honest. But it'll be cool. That's kind of the only thing driving me at this point. It'll look cool. So we really gotta do this part first, right? Link this over, right, the bridge portion here that comes over with the elevator on both sides, synchronize that, align it properly, and attach the wound part to that assembly. The wound part then wraps around the neutral point, and we're able to do that with this new plier tool. We can make a really tight loop, as we saw here with this metal wire. Once we do that, So we attach that in place, we put it in neutral, we'll do the anchoring whatever later, put it in neutral, and then we can, again, like before putting it in neutral, we need a, you know, twin thin diameter straw going down the middle here. So friction lock module installed, the 2 rods installed. This whole tail mechanism assembly put in neutral, and then this can then, we can then put a rod here, right? That'll put it in neutral position here. And then once we have the rod in, then we can like, you know, pull this back and assemble the brass fastener pin. So it's a lot of steps. It's really, you know, you gotta just work through constraining it slowly, one by one, so that you get to a point where everything's assembled. And it's kind of like a puzzle in that sense. You gotta think ahead. You can't just go in willy-nilly. So yeah, just tail assembly, right? Create the geometry here. One continuous piece. I don't know if we have enough wire to do one continuous piece actually, but we'll figure that out. Do that assembly, attach the little curly helical bit that attaches to the neutral point. Neutral point again requires the twin straws inside the main large diameter straw. Let's assemble that whole thing, free the anchor, don't do the anchor yet, in case we need to do adjustments. Once that's in neutral, then we can lock this neutral in place, and then we can lock the elastic band in place with this brass fastener anchor. And once this anchor is in place, then now we're pretty much all set with the mechanism. We'll just make sure everything is tight. And this spar is really kind of optional, I guess. You'd have to make sure it this is gonna be kind of hard actually, because if this straw needs to bend over that's gonna cause a lot of tension. So we might have to cut this in half and then adjust it, and maybe have like another spar somewhere here to really pin down those two pieces. I'm not sure, but we definitely need a secondary spar. We don't want one spar in the wing, because that'll make the trailing edge a little bit weak for this large area here. So yeah, that's the plan going forward. Tail assembly mechanism, and then work our way front, and then eventually constrain this elastic band in place after we do the pin here. So it's a lot of thinking, a lot of design work. So I'm sorry if I like bored you to death. Oh god. Yeah, but that's just kind of the business, you know, of mechanisms. You can't just, it's a lot of thinking involved. It's not just go ahead and build something. I guess, you know, for Legos it would be easier, but we're not dealing with Legos. We have raw materials and parts, and we need to make them work together. So once that's done, we could start to build up the rest of the upper fuselage, or we could work on another mechanism for the landing gear. Hey, that'll be fun. But yeah, that's pretty much it for now. And I think we're just about out of time. We're at 1:30. Got approximately 30 seconds left. So, all right, guys. Sorry, today's been a long one. A lot of technical difficulties, right? But hopefully next time will be smoother. We won't have these issues. So yeah, thanks for watching, and I'll catch you guys in the next live stream. All right, take care, guys.